So that will be our indicator for good scenarios or good securities that move in the same direction as the market. The vaccine producer here always moves in the opposite direction, right? So the vaccine producer is down, the market is up, and vice versa. So we're looking for something that moves in opposite directions, right? So that will be our measure for securities that give you money in bad scenarios, that were negatively related to the market. Fortunately for us, statistics and probability theory have a measure for the movement between two variables, and that is the so-called covariance. Let's start with the bottom formula. So the covariance here is also abbreviated with little sigma, but then you have two variables, or two returns. So this is the covariance between a stock, K, that could be the vaccine producer, and the market. Right? So you always have two parameters. And then here, it looks a little bit like the variance, but instead of squaring a term, you multiply two terms. It's like a cross product. The first term comes from the first asset, from the stock, and the second term comes from the market. So what you're looking at is, first of all, this is the question, how is the return of that security compared to its expected value? And then you multiply that with, how is my return of the market versus the expected value of the market? And then you multiply those two numbers. Now, coming back to our example, so if these two here are both positive, so they're both high, the result will be positive. If they're both negative, so both are below their expected value, you have minus times minus, and the result also becomes positive, right? They're high at the same time, low at the same time. And then finally, multiply with the probability. And then the opposite case, this here could be negative, and this positive, right? So that would be one, and then the other would be this is negative, and this is positive. So they move in the opposite directions. This is below its mean, and this is above, and vice versa. So it will produce a negative covariance. So that's the important measure that basically now is helping us to identify whether we get money in good or bad scenarios. We use the covariance. Unfortunately, the covariance has a unit that is not very easy to interpret. So to actually use this as a risk measure, we actually standardize the covariance by dividing by the market variance. So we've already computed the market standard deviation volatility, so this is just the volatility squared. And it's the same basically for every stock. So our final risk measure called beta is the covariance divided by the, between two assets divided by the variance of our indicator for the market. Right, so this will basically put us on a scale, and we're going to look at what the kind of range of values is that we can get. But in contrast, the volatility was strictly non-negative, right? Or never negative, it's strictly positive or zero. The covariance can take positive and negative values, right? So theoretically, you can have any results for that. Right. Maybe let me kind of introduce. Well, let's skip this for time not to make it complicated enough. So I have a brief talk with one student in the break about probability theory formulas. So I will always write down all the formulas you need, like here. But I can, of course, not go as deeply into this like you would do in a statistics class. So if there is like a demand from your side to have maybe some readings about basic probability theory, I can dig this out. So for example, there is an appendix to an econometrics textbook where they basically review kind of basics of probability theory. So if you're interested in that with some more examples, then I could share that. I will always show you the formulas here and an application in finance, but we cannot go so deeply into a standard statistics course and review everything. So please let me know if you need some more material in that regard. So there is what I was thinking about, there's another number that you can compute called the correlation. It's highly related to covariance, but let's do that next week. So let's start with the covariance. Do you have any questions regarding how to compute this, the approach? Right. So remember that the variance of the market is already something that we computed. Right? So in our example, that is basically this number here, the 9.2 squared, right? That's the volatility, so the variance of the market is 9.2% squared. So basically you have to focus only on the covariance term. Okay. So again, we have 5 rows, 5 assets, so compute the so-called beta, this risk measure that measures the covariance with the market. And for the final row, that might seem a little bit awkward to do this for the market itself, but you can use the formula and come up with the result. So you have to figure out what the covariance of the market is with respect to itself. Right? So look at the formula and come up with the result too. Right? So this will probably take a little bit longer, so I give you 10 minutes to type everything in. If you have questions in the meantime, just raise your hand. Right. If you haven't finished your computations, you can still kind of do this on the side. So let's do this kind of in a long version. I've just entered a blank slide here because I need a little bit more space, so I will write this down fully. So I'm going to pick the vaccine producer here. So let's compute the covariance first. So we, as usual, have our probabilities that we need to multiply. And now I take this, what I call a cross product. So I look at what's the return of my stock, so that was 50%, minus its expected value, that was 6%. And then I multiply it with the same difference, but of the market. So the market has minus 10% return and is down, and has an expected return of 8%. So I subtract that. Now I just do that for all scenarios. So I have the scenario with 50% probability. Just leave a little bit more space for my notes here. So that's minus 5%, minus 6%, multiplied with 11% plus 11, minus 8%. And then the final scenario has 30% probability. And again, minus 5%, minus 6%, multiplied with 15%, minus 8%. Now, let's look at the signs of the terms of parentheses. So, the first one here, 50 minus 6, that's positive, right? And here we have minus 18, so that's negative. In the second scenario, the vaccine producer is below its expected value, so that's negative, while the market is above its expected value. And then finally, we have negative and positive again. So it's always in the opposite direction, so the cross products are always going to be negative. So the final result that we should expect is a negative number. Then let me kind of do the same thing as I did before by multiplying through the parentheses to see kind of how large the terms are. So we have 20% multiplied with minus 7.92%. And again, we have this weird squared percentages in there. If you want to do this, you could also write this. Percentage squared plus 50% times minus 0.33 percentage squared plus 30% times minus 0.77 percentage squared. Well, the problem, similar to the variance, is that those percentage squared numbers are difficult to interpret. Right? That's why we're dividing by the market variance at the end to get rid of all those percentage squares. They cancel out. So the final result of the beta will actually be unitless. So it's not percentage, it's just a raw number. But what you can see by this comparison is the magnitudes of the numbers. So this is close to 0. This is close to 0. So basically everything here is determined by this term, right? That's minus 8%. That's 8%, right? And these don't will add up to 1%. So probably more than 80% of the value of the beta comes from this from this one scenario. Right? And this is pretty similar to the volatilities, that you have one outlier, and that big outlier is determining kind of the direction. Now the rest is a little bit of calculated work. So the beta is going to be the covariance of here our stock. I think we've given it the number 4 with the market divided by the variance of the market. Remember, the variance of the market is 9.2% squared, and if you just plug this in your calculator, you get minus 2.36. I don't have the intermediate step on my notes here, but I hope that's kind of enough to give you an intuition about kind of how these numbers look like, and so on. So my final result here is minus 2.36. Let's see, have you been able to compute some other betas in the supermarket? Yeah, value?
We have something for the supermarket. 0.27. Between something between 20 and 27.
Have a similar number, but not exactly.
Minus 9.
So I think that the low number was already in the right ballpark. 1.5. So the reason why we see that it can't be negative is basically that this is above the expected value, that this is below when this is below. This is above when this market is above, and this is above when the market is above. So it must be a positive number. They're always moving in the same direction. You see that the magnitude of the number is pretty small, and this was predictable because the volatility is small. Right? So things that have small volatilities have also small betas. Right? So the volatility is 1.4%. So the magnitude of the beta should be low. It can be low positive, low negative, but it must be low. Right? Compared to the vaccine producer had a large volatility, and again the order of magnitude, either very negative or very positive, must be high. Right? So volatilities and betas are somewhat related. You cannot guess the sign from the volatility of the beta. But if the volatility is low, the beta must also be low. So here's only car producer. Someone manage?
1.38.
Yes, 1.38. So positive and larger than 1. The electric car manufacturer. Okay, so the result is 2. It's exactly 2. And then finally the stock market. Yes, 1 is the correct result. And it's always 1, by the way. So doesn't matter which numbers you pick for the stock market index, it's always 1. So again, what we see is that the ones who have high volatility, they also have high betas. However, we can't guess the sign of the beta from the volatility. We have the one that has a low volatility also has a low beta. And the market beta is always 1. It must be exactly 1. So,
sorry.
yes.
So I compared to what?
Yeah,
If
so
you say, I mean, I get the concept of if the volatility is small, then it means the data will also be small, but small in.
yeah, so